Discussions around psychedelics almost exclusively focus on the peak, the 4 to 8 hour window of vivid hallucinations, dissolved boundaries, and profound realizations. The days following that peak are usually categorized as the afterglow. For decades, this period was dismissed as a simple emotional come-down, or perhaps the lingering relief of surviving an intense psychological event. Treating the experience as over once the visuals stop ignores a critical biological reality. Long after the substance has cleared the body, the brain remains in an active state of physical transformation. In 2020, researchers at Johns Hopkins tracked healthy volunteers after a single high dose of psilocybin. They conducted functional MRI scans 1 week and 1 full month after the session to see if the brain's baseline had actually shifted. This chart compares a standard brain's amygdala reactivity to the results found 30 days after the dose. On the left, we see high reactivity to fearful stimuli. On the right, the amygdala response remains significantly blunted. Beyond scans, the participants reported a measurable drop in trait anxiety, the baseline level of stress and apprehension a person carries throughout their life. Because trait anxiety is typically considered a permanent psychological disposition, seeing it shift weeks after a single short-lived chemical exposure suggests the drug triggered a change that outlasted its own presence in the bloodstream. This long-term change is driven by neuroplasticity, the brain's physical ability to grow new connections and reorganize its communication networks. In the cortex, classic psychedelics trigger a burst of structural growth. Neural dendrites begin to rapidly sprout new branches, reaching out to form fresh synaptic connections with neighboring cells. This accelerated growth creates a temporary state where the mind is physically more malleable, more capable of forming new associations and revising old, stubborn patterns. The gentle, spacious feeling reported during the afterglow is the subjective sensation of this physical process, a brain actively knitting itself into a new shape. This level of malleability is usually reserved for critical periods, specific windows in childhood where the brain is exceptionally sensitive to experience and environmental input. As we reach adulthood, these developmental windows naturally snatch shut. Our neural pathways harden, which helps stabilize our behaviors, but makes them harder to change. Research published in 2023 demonstrated that psychedelics can physically reopen these closed critical periods in adults, returning the brain to a state of childhood-like receptivity. The longer the drug's acute effects last, the longer the brain stays plastic. Ketamine opens the window for roughly 48 hours. Psilocybin keeps it open for 2 weeks, LSD for 3 weeks, and ibogaine for up to a full month. The depth of the initial chemical experience dictates how much time the brain has to physically rebuild itself. This openness carries a significant biological risk. Neuroplasticity is strictly neutral. It has no inherent preference for healthy patterns over harmful ones. A highly malleable brain can just as easily consolidate unhelpful habits, traumatic responses, or paranoia if the environment during the afterglow is negative or chaotic. This neutrality explains the shadow effect, where a difficult or unsupported experience leaves an individual feeling more fragile and emotionally raw than they were before the trip. A reopened critical period is a state of absolute vulnerability. It requires a highly controlled and supportive environment to ensure the new connections being forged are actually constructive. This window of vulnerability is the reason modern clinical protocols focus so heavily on the practice of integration. Therapists schedule the most rigorous psychological work for the subacute window, taking advantage of the brain's temporary receptivity to help the patient establish new habits. While the trip provides the initial insight, the afterglow is the time where that insight is actually built into the brain's architecture. The psychedelic compound acts as the catalyst for a brief, highly malleable window, but the true therapeutic change is engineered through the work done while that window remains open.